Hello, my name is Gabriel and welcome to a new episode of Concierge.js. In this one we will discuss a little bit about the improvements that I did for the performance tests visualizer. Previously we had already this page called performance where we could start tests, and the problem was how do we do validation. In a previous episode we have tried to ask an LLM to do the validation, so we were giving as input the ground truth, which is the information that we have in the database, and then the LLM response, which is the information the information which was produced during the test previously, and we were asking the LLM to do a comparison. Then we have noticed that if we don't specify which of the fields should be present, some of the LLMs were cheating a little bit and were not validating the response thoroughly. So we have improved the prompt in the previous episodes, and now it is super easy to validate. But we have started to gather a lot of batches with different descriptions, and it is starting to get complicated to compare them. We can go one by one and remember the values. So the important values in our case is this one, how long the responses took, if it was a concurrent or a sequential, and if it was valid or invalid. And that was difficult to manage. So I have created this new page, View Performance Dashboard. Here there is a graph with all the batches that ran. On the y-axis is the accuracy, so how many of the responses are valid, and on the x-axis is the response time, so how slow an LLM was. We also, when we hover them, we also see the description of the test, and this allows us to better see which improvement was made in order to achieve this result. So our target is to find something with 100% accuracy and an average response as small as possible. If we can consistently get lower than 10 seconds, it's perfect. It is easy to explain that, okay, the system is slower than a traditional system because we use LLMs, and look, you have all the freedom in the world to customize how your pages look like. If we manage to be at about 5 seconds, 5 seconds like a badly optimized website, or one that runs slowly, or what we call you have a slow computer, so on and so forth. Then I have made this table with statistics, and I could filter by one or the other, but it was a bit annoying. I wanted the ability to filter by average speed and accuracy, so by holding the shift, now we can filter by both of them. And then I wanted to be able to hide the colors. By clicking here was kind of easy, until I have run a test for Qwen 27B, and I realized that it's very annoying to find all Qwen 27Bs, so I did this. So I used the search of the browser, but by using the search of the browser I could not unclick anything. So I have implemented deselect all, and now we have a new search here. We have 27B, and we can select the two models that we care about, and now we can hover. So 27B with no think configuration starts to be fairly decent, and it's significantly better than think. In concurrent runs, thinking slows down the model a lot because a significant amount of the GPU is busy. However, with no think, we end up having better results with concurrent than with sequential. So this is the kind of insight that we can gain by filtering the results which we already have. Another usage for this is when we have a feature, for example, for caching, all the tests that were made in order to test the caching functionality, we can see what has happened. The story that this graph tells us is that while caching was being implemented, everything was all over the place. At some point, we did have some success, but not because we were using the better caching, but because we had basic cache in the name of this test run. Basic cache is the default cache that we have all the time. And while using cached results, everything was significantly worse than we had before. So as we concluded in a previous episode, we have abandoned that branch. So this is the performance dashboard. The goal of this dashboard is to be able to accept VLLM or Llama CVP in the future configurations on our GitHub page, apply them, run the tests, and get some feedback to the creators of that LLM or that backend or that branch. So it's just another tool that we use in order to test LLMs with the mention that ours is tailored around information retrieval, the needle in the haystack type of tests with tool calling. The evolution of this performance dashboard will be to also support multiple prompts. For now, there is no delimitation in the batch control between the prompts that were used during this testing. We only manage this guest search prompt, but this will be very important because in the future, as we have the prompt management functionality, we will be adding more and more prompts, which will be more complex, and we have to test these as well. Because at the end of the day, if we have one model that is super optimized for one task, it does not help us very much. If that model is very, very small and we can fit more of them in the memory, okay, it is one way to go. But if we have to choose one model that fits in one GPU and can serve one client, it should be able to handle properly, at least in terms of accuracy, all the prompts needed by that customer. So in the end, this is the evolution of this. Probably there will also be filtering by model type, because there is also the question, out of all the models that we have tested, which one performs the best for all the prompts that we have. So from now, for now, we are looking at everything, but we have two directions that we care about. We have to look from the model's perspective at which prompts this model is the best and why, and we have to look from the prompt's perspective, me as a prompt, which model serves me the best from. So this is the state of performance dashboard. Thank you very much for watching, and see you in the next episode.